Hello friends, how are you doing? It's time for another daily problem. It's Spanglish. Okay, so this one was sent to me by via Facebook. If you have a question, a math problem, Math Olympiad, if you would like some help, you can post it in the comments. I will try my best. So, for today's problem, this one was sent to me by my friend Sai Krish from India. It says, call a finite set S of positive integers an LS set if the sum and least common multiple of its elements are both equal. So for example, the set 1, 4, 5 and 10, if you add all 4 elements, it's 1 plus 4 plus 5 plus 10, it's 20, and the least common multiple of those elements is the same, it's 20. Okay, so I'm gonna try to walk you through my thought process, just in case that helps. This is a yes or no question, right? I forgot the question. Okay, so there we go. The question is, does there exist an LS set containing exactly 100 elements? Right? So, this is a yes or no question, right? Even if it's the kind of exam would you have to explain your answer, the basic question is simply yes, no, right? So you have to decide whether you believe the answer will be yes, the answer will be no, because that will lead your process. So if you believe the answer is yes, all you have to do is show an example, right? So your efforts should be focused on building such a set, right? If you believe the answer is no, you should give an argument, a general argument, as to why no such set can exist, right? So the thing is, you choose yes or no path based mostly on your intuition, which is simply a fancy name for calling back things from your memory. Have you done similar problems? What were the answers then, right? So I have never done a problem that involved the least common multiple. I have done several of these in which it was the sum and the product. So in all of those, the answer was always yes. So I thought, well, the answer is probably yes, right? My first attempt was to build a bigger set out of this one. I had no luck, right? So, okay, so let's go. The thing is, you have two elements in the set in which the product equals the least common multiple. So if you had two such numbers in your set, you could have every other element be one that would add to the sum but not to the product. So maybe that's the idea, right? If that were the case, you choose two elements to prime, or at least relatively prime, and you will have that p times q, which would be the product and would be the least common multiple, is equal p plus q plus 98, because you have 100 elements and we've decided that the rest will be ones, right? So this is simple factoring trick. We would do this, add 1, so this would be p minus 1 times q minus 1 equals 99, which could be 11 times 9, right? But then p would be 10, q would be 8. That's not exactly useful. So based on this same idea, we would like to have a lot of ones, because they add to the sum but do not change the product. And we would like to add 2's, right? Because if ones are not enough, we'll 2's simply add an extra one, right? So we're not going with primes or relatively primes. I simply decided to go with 10 and 32. Right? Why those two numbers? Well, a couple of inspiration from here. So if these were the only numbers that were significant to the least common multiple, the least common multiple would be 160. And that's a big enough number because we could do that with 100 elements, right? So our set S would be 32, 10, and then a bunch of ones, right? Exactly 98 ones. This does not work, clearly, because 32 plus 10 equals 42, and 160 minus 42 is 118, right? But these ones add up to 98, so we're missing 20. So the answer is really simple. We just change 20 of these ones to 2's. The least common multiple is not affected because 2 is one of the divisors of both 10 and 32, so nothing changes really, just the sum. So that does it. We just built an LS set with 100 elements. It has exactly 20 2's, and then the rest are ones. So 98, so those are 78, right? 78, 80, 100 numbers. And that does it. So the answer is yes. Of course, I've only given one example, but that's enough. And we could easily see that once you give one example, you have infinite examples, right? Because you could do S, in which every element is multiplied by the same prime number, or at least relatively prime to both your big numbers, right? To your significant numbers. So we could do another set that is 3 times S, in which every element is multiplied by 3. So the sum is 3 times the sum we had, and the least common multiple is also 3 times more because we added a 3, a new factor we didn't have. But we could do this with 7, or with 11, 13, any number that is relatively prime to this, right? So if we have 1, we have infinite of this. This is not, I'm not even sure if this is the smallest one we could build, but this is enough, right? The answer is yes. We have evidence because we just built one, and we have confidence that we could build infinitely many more, right? So that's it. We did it. So thank you, Krish, for your problem. It was really interesting. And if you have another problems, you could post them in the comments. I could try to solve them. I cannot solve everything. And I will post a video if I believe it's interesting enough. Either English, Spanish, or Spanglish, right? Okay, so thank you, and take care.